Hi, welcome to our first units video. You should have in front of you the note packet. We are, of course, starting with Unit 1. This is called Foundations of Geometry because we will really begin with many of the foundations and vocabulary terms and theorems. Section 1, points, lines, and planes. So we will start very basic with a lot of vocabulary today. And in fact, the very first sentence we have here, I'd like you to fill in the two words undefined terms. Undefined terms. So let me go back and read that. The most basic figures in geometry are considered undefined terms. The three undefined terms in geometry are points, lines, and planes. So we're going to spend quite a bit of time defining them and describing them. The reason they're considered undefined is it's very difficult to just give a one-sentence definition. They need to be described with all of their characteristics. So if you would go ahead and turn your paper so that you can write on this grid here, we are going to, like I said, talk about these undefined terms, point, line, and plane. So I'm going to start here with a point. The model of a point looks like this, probably what you would expect it to look like. It looks like a dot. And then whatever the name of the point is, it's written as a capital letter. So when you see a model of a point, it looks like this. It's drawn, as I said, as a dot. So it looks like a dot on paper. It is named with a capital letter. Capital letter. A couple facts about a point is it does not have size or shape. It cannot be defined by a certain size. So does not have size or shape. It's one of the most basic ideas in geometry. And then for words or symbols, sometimes the capital letter is how we name it. Or sometimes you can actually write the word point and then whatever the point's name is. Okay, so those are some of the facts about a point. Moving on to a line is defined by 2 points. So I'm going to start with 2 points. I'm going to call point A and point B and leave a little space in between them. And I'm going to draw a line through both points. So you're connecting both points, but you're going to go past either point, and then you're going to put arrowheads on either end. A line extends in either direction forever, which is what the 2 arrows indicate. Kind of like when you would graph a line in Algebra 1. It is drawn with, I'm just going to put here 2 arrowheads. Drawn with 2 arrowheads. It is named by 2 points. So there's 2 items we're going to write here. Item number 1, it is named with 2 points. Or sometimes there is a lowercase letter on one of the arrowheads. So if I go back up here and put like an M, that would be what we could also name it by. So I'm going to write lowercase letter. Okay. Some facts about a line is it does not have width or height. Does not have width or height. Width or height. Okay. And then words. We can name it with the 2 letters. So put your 2 capital letters, your 2 points, and then you want to actually draw a small line above it. Or we would name it with this lowercase m that we wrote, or line M. Okay, so those are the facts about a line. Lastly, plane. Planes are often drawn, let's actually start with what it's drawn with. It's some sort of 4-sided rectangle or parallelogram. Most of the time it's a parallelogram. So let's write the word parallelogram in the drawn section, and then I'm going to come back up to the top for the model and draw a parallelogram. Now a plane, like a line, extends all directions forever. So even though I've drawn a finite parallelogram, it goes all the way out in all 4 directions. There's always going to be 3 points on a plane, a minimum of 3. So I'm going to use points X, Y, and Z. And then that brings us down to named by. A plane is named by 3 points. So there are 2 items here, 3 points. Or just like a line, we had this lowercase letter. We're going to have the same thing here, only it's a capital letter. So I'm going to write an S in the corner. This is also called plane S. So I'm going to write here capital letter. A fact about a plane. It goes on in what I said earlier, goes on in all directions forever. Goes on in all directions forever. Okay? And then lastly on words, we can name this plane with our 3 points. So I would say plane XYZ, or I could call it plane S. So I would say plane capital X, capital Y, capital Z, or plane S. Okay, so those items we wrote there kind of sum up points, lines, and planes. So let's move on to the next page. So go ahead and turn the page here and get to the next part. Okay, let's go to the top here and let's discuss how lines and planes intersect. And this actually brings us to our first set of rules. Geometry is all about rules, and we call some of these rules are called postulates. Let me write that at the top. Postulates, and some rules are called theorems. And they both are just basically rules or properties. So I'm not too worried about you knowing what is a postulate and what's a theorem. I really want you to understand the rules. So what we're going to look at first here is how do 2 lines intersect and how do 2 planes intersect. So when you look at these 2 lines, I'm going to add a big point right here. And some of these postulates might seem really obvious to you, and we have to start somewhere. So some of them are pretty obvious. One of the rules or postulates that we're going to talk about is 2 lines always intersect in 1 point. So I'm going to write 2 lines always intersect. 2 lines always intersect in 1 point. And that is actually a postulate. And so if you think about it, you could never have 2 lines intersect in more than 1 point. If you did have that happen, you would actually have some sort of curved line, which is impossible, therefore it's no longer a line. Planes always intersect in the same way. And so you can see there's one plane going this direction. If I kind of shade in right there, there's one plane. The other plane is going here. They're intersecting right here in this darkened area. So obviously they're intersecting in more than 1 point, but this is represented by a line. And in fact, I'm going to extend this line out. So planes are going to intersect in multiple points, so we call that a line. So I'm going to write here planes, I guess I should back up and write 2. 2 planes intersect in 1 line. So I'm actually going to circle here. The 1 point is the intersection of the 2 lines. The 1 line is the intersection of the 2 planes. And so these rules seem pretty obvious, but they'll come in handy later on when we're trying to discuss different types of intersections. So let's skip these 2 at the bottom, and I want us to move on to page 3, where we have segment ray and opposite rays. And so we're going to wrap up this video with these last few vocabulary terms. And it's structured exactly like I did on the first page. So let's start with a segment. I'm going to use points A, B. So a segment, go ahead and draw points A and B. A segment is basically a line that ends. So connect A to B. And I have just drawn a segment. So it is drawn with 2 points. Drawn with 2 points. It is named by both endpoints. So we consider A and B the endpoints. It is named by both endpoints. Can we zoom in here a little bit? Named with both endpoints. Facts about a segment. It is actually part of a line. Part of a line. And then words and symbols, we name it very similar to a line, only we put a segment above it. So you put the 2 points next to each other with a segment bar above it. Whereas what we did on a line, if you remember, we had the 2 points next to each other with a line symbol above it. Okay, moving on to a ray. A ray is a combination between a segment and a line. So I'm going to start with 2 points again, points A and B. And I'm going to start by drawing a partial line. So from A, I'm going to go through B and then put an arrowhead on it. So a ray has one endpoint and goes on the other way forever. So it is drawn with one endpoint and one arrowhead. One endpoint and one arrowhead. It is named by the 2 points. Named by 2 points. Facts about a ray. It begins with one endpoint and goes on forever. Begins with, I'm going to abbreviate endpoint. Begins with endpoint and extends in other direction forever. It begins with endpoint and extends in other direction forever. And we draw it very similar to our segment. So it is A, B right next to each other. Now the symbol above it is a miniature ray. I'm going to have to start above the A and put the arrowhead above the B because the ray has A as the endpoint. It would be incorrect for me to name it BA with a ray above it because that would indicate B is the endpoint, and that's not the case. All right, finally, let's finish out with opposite rays. Opposite rays look like this. There are actually 3 points, F, G, H, and there are 2 rays connected. So I'm going to go from G over to H and make a ray, and then I'm going to go back to G and go through F and make a ray. So actually it looks like a straight line. So it is drawn, I'm going to write here, looks like a line. And it's named by 2 points. And in parentheses, I'm going to write order is important. And you'll see why in just a minute. Order is important. Facts. Basically, opposite rays are 2 rays with a common endpoint. 2 rays with a common endpoint. I'm going to abbreviate endpoint again. Feel free to write it out for your notes. And then finally, words or symbols. We would name this by starting with G. I'm going to address both rays. G, H is one of them. So start with your G and your H and draw your ray symbol above it, where G is the endpoint, so that side does not get the arrowhead. The other ray is GF. So when I write it like this, G is still the endpoint and F is where the arrow is. So it looks like this, and when you draw it, you can see they are opposite rays. It's hard to see that until you actually draw it. Okay, so that kind of brings to a conclusion here the vocabulary from this section. So if you would go on to the next video, we will go ahead and finish this section out, and then we will be ready to move on.